Hey, it's Mr. Allred, and we're going to talk about functions. Topics in this series of videos are, what is a function? That's a good question to ask and answer for where we're going. And if you know a little bit about functions already, you'll recognize the vertical line test, domain and range, function notation, evaluating functions, and you may have some experience with the implied domain. So we're going to cover that in this set of videos. So, what is a function? I have some big bold words here, so they must be important. But a function is a rule that assigns each member of an input set to exactly one member of an output set. So by rule, I could mean a graph, an equation, just some type of mapping. An input are basically things we might put into a machine or an equation, and output is what the machine or the equation might give us back. And the thing that makes this a function is every input has exactly one output. Okay. We'll see that in a moment, but I drew a little diagram down here. This little box here would be my function or my machine, if you will. It has a rule, it has some stuff inside of it. But what I've got here is I would put a lowercase letter in, and the uppercase letter would come out. So I'll kind of demonstrate that on the next page. But something goes in, it's kind of worked with within the machine or the function, the equation, and then something comes back out. So here are some examples of functions, and one thing I put up here is each question has exactly one answer. So there's exactly one again. And by question, I mean the input. So on the first one over here, I have little a going to big A. Okay, so the question is, where does little a go? It goes to big A. Or if I put little a in my machine, what comes out? Big A comes out. So in this one, little a goes to big A, little b goes to big B, little c goes to big C. Every input goes to exactly one output. It is a function, and that's why. The second example might be harder to relate to, but I have 1 going to A, so I stick the number 1 into the machine and out pops A. I stick the number 2 into the machine, out pops A. So here's a good example of the true meaning of the function. Okay? When I stick 1 in, a very specific thing comes out. When I stick 2 in, a very specific thing comes out. So it's okay that 1 and 2 make the same item. That's not a problem. 3 goes to C, it's a function. The third example kind of shows us where the function falls apart. If I put 1 in my machine and I get out A and B, or sometimes A, sometimes B, that's a problem. So this 1 going 2 different places means that 1 does not give us exactly one answer. Okay, so if I ask you the question, where does 1 go? Sometimes you might say A, sometimes you might say B, you might say both, but there's not one consistent answer to that question. Okay, so that's kind of like if we were working a problem and some people got one answer and other people got the other answer. That's not good. Okay. 2 going to B is not a problem, and 3 going to C is not a problem. But if our function falls apart anywhere, it's not a function. Okay. So when we ask that question, there has to be one consistent answer. Okay, let me get that part off of the C there. All right. The last one I have over here. A goes to 7, B goes to 7, C goes to 7. It's okay that every question has the same answer. Okay, that is a function. The only time we have a problem is when one question has multiple answers. Okay, or you plug something into your machine and you don't know what's going to come out. Okay, it could vary from time to time. So that's trying to clear up when you don't have a function. So we're going to work our way up to functions as graphs, but to think about the function as a graph, we usually let the x values be the input and the y values be the output. Okay, and usually this is thought of as every x only has one y. So here's that only one or exactly one idea again. Every x has exactly one y. So in the first one here, it says 1 goes to 5 goes to 7, negative 2 goes to 4. So these are like x, y points. But the problem is this, no, there is no problem. Because every input, 1, 2, 5, negative 2, has one answer. So this is a function. Okay. The second example I have down here, 2 goes to 4, 3 goes to 4, that's okay. Two different questions can have the same answer. But 2 going to 7, that's an issue. Okay? Because 2 can't go to 4 and also go to 7 at the same time. That's not exactly 1. So that's not a function. So let's see what that looks like with a graph. Okay, but keep in mind every x has only one y, and we can do that in points. So in a graph, if we're given a graph, you may have heard the vertical line test. And what the vertical line test says is that we'll drop a vertical line anywhere on the graph, and if it touches the graph more than once, it is not a function. Otherwise, it is a function. So I'm going to pick something up here, and the first graph I have over here is a squiggly. I can drop a line anywhere on here. Sorry, it's not straight. But anywhere I drop a line across here, it only touches the graph one place. That means the negative 2 for x only has one y. The 0 for x only has one y. The positive 2 over here for x only has one y output. This is a function. The second one here is a straight line. Wherever I come across here, any x I pick, I'm dropping a line straight down. I only hit the graph once, so that means every x only has one y associated with it. So that is also a function. The last one is the counter example, a circle. So if I come over here to negative 2 on the graph, and this won't be exact, but there's a point up here where x is negative 2 and y is 2 something. But there's also a point down here where x is negative 2 and y is negative 2 something. So if I drop a vertical line right here, that vertical line for a single x goes to two different y's. And that happens in multiple places. Ooh, wasn't expecting that. Let's see if we can fix that. Okay. So it happens there at negative 2. It happens in lots of places on the circle. So this is not a function. So certain x's have more than one y associated with them. Okay. So let's talk a little bit about the input and output sets. We have various names for these in different disciplines working with them. But the inputs, we've already looked at them as being the x values. These are sometimes referred to as the independent variable because they're the ones you would pick. You would pick this value to plug in. Okay. The mathematical term for these inputs is domain. Okay. Domain. So these are usually thought of as x values or the ones we're plugging in. The other side of that, the outputs. Hold on, there's a dog. Apologize, my dog wanted to go outside. So here, the output values, we've already kind of associated those with y's as we've looked at the graphs and as points. Sometimes it's referred to as the dependent variable, the outputs, because they're the ones you're calculating. They're dependent upon whatever you plug in for the x. And that's true for most graphs. also known as the range in some places. That's the mathematical common term here. So let's see here. Let's look at domain and range, and then we will move on. So here state the domain and the range of the functions. So we got two examples. The first one over here is a collection of points. The points are 2, 4, 7, -3, 4, 1. So remember the domain are the x values. So that domain would be the set with 2, 7, and 4. And then the range, as we just said, are the y values. So in this case, that would be 4, -3, and 1. And you can put those in order or not. The other one over here is a graph. And you could try the vertical line test on it and see that it is a function. But what we want to mark here as far as the domain would be the x values that we're using. And since this is not just individual points, it's an interval, we'll use either interval notation or inequality notation. So for x's, the smallest x we have, it comes up to -3, but not included. And it runs along here, let's maybe highlight this way, over to 1. Okay, and that 1 is included. Another way to write that is as an inequality. -3 is less than x, less than or equal to 1. So we can use interval notation or inequality notation. Then we can talk about the range, which we just talked about were the y values used. And the y values look like they run this way as far as what is used, up and down. So let's see here. Ooh, it disappeared on me. So the smallest y value is down here at -4, and that is included. And the largest is 0. And be careful because here in the middle it's included, whereas on the end it's not. So it is included. So that will, in inequality notation, run from -4 less than or equal to y for our range, less than or equal to 0. So let me highlight that. So that's what we have in that example. So let's do one more example with the domain and range from a graph. So here's another set. In the first one here, we have a parabola. It looks similar to an x squared. You may not know much about that yet. But what you can see is these little arrows at the end, meaning, of course, it goes up forever, but it also kind of comes out forever. So that domain, when we talk about the x values, is going all the way to the left forever and all the way to the right forever. So we could say that is -infinity to +infinity, or all real. But the range, it may go up forever, but it never goes below that -1. So the range here, we could say, starts at -1 and goes to infinity all the way up. Once again, we could put that into an inequality notation, which would be y is greater than or equal to -1. The other one over here, we're running out of time and what I can record. So let me see if I can just put it down here really quick. The domain, and well, no, let's save it for the next video.